Hello. It's Colin here from Computer Science. Grade A, computerscience.com. Grade A, computerscience.com. And today we're going to be looking at big data. What it is, and its characteristics. Yeah, so by the end of this session, you'll know what big data is and what its characteristics are. Okay. So, what is big data? Big data. Well, look, you're going to see big data is big data. There's a lot of data in big data. That's the whole point. There's so much data. We are in a world now where we are producing so much data from our phones, from our tablets, from our computers. It's just amazing how much the data, just in the last few years alone, has been generated from computer systems, and it's just mind-blowing. So that's what big data is all about. What do we mean big? Well, when we talk about big data, we talk about multiples of zettabytes. So for instance, 1 zettabyte is 1 trillion gigabytes. Yeah, 1 trillion gigabytes. So you know what you've got on your phone. You might have, 60 gigabytes on your phone, perhaps, 32 gigabytes, 64 gigabytes, something like that. And in this case, we are talking about 1 trillion gigabytes. We're talking about the data capacity, multiples of zettabytes. We're talking about the data capacity, to take the data capacity for the world. So it's a lot of data. Yeah. Big data. So for example, a few examples here, we've got Amazon. They generate big data because they're taking, over $250,000 in sales every minute. Every 4 minutes is over 1 million in sales. So there's all that information that is being sent to and from customers just to be able to recognize those transactions. Then you've got Google, 3.5 million searches every minute, 3.5 million searches. And they also, when you make the search, Google is going to return a load of information that will help you to get the information you're looking for. So there's all of that. Then you've got YouTube. We're just talking about 3 here. YouTube, 4 million people watching videos every minute. 4 million people. Wow, that's a serious amount of watch time, video time on the computer. The bandwidth that's required for all of that. It's amazing. And we're just talking here about 3 major websites, 3 major companies. So there's a lot of data here. Big data generates now, as of 2014, so now we're in 2021, so that's, a good while ago, 7 years ago. So it's obviously increased since then, but 2.5 exabytes of data generated each day. It's probably double that now, really. 2.5 exabytes. Now, 2.5 billion gigabytes. Yeah. Every single day. 2.5 billion gigabytes every single day. And the Utah data center is one of the data centers that handles all of that. And it can store 12 exabytes of data. Now, when we were talking about the zettabytes, which one was it? We were talking about zettabytes. There we go. 1 trillion, not 1 billion. 1 trillion gigabytes. So we're going to need a lot of data centers. So what we're going to talk about here, the whole big data thing, really is for AQA A-level computer science, because we'll find it in that syllabus. But it's also for computer science students and those who want to know more about big data, because it's a great industry and there's some great opportunities for students of computer science, and it's something well worth looking into. So here it is. So, big data applications. So, we can look at, we've got two applications here. So, imagine collecting the data from 6 billion cell phones, 6 billion cell phones, and you'll be able to say whether cell phones cause cancer. So if you can collect the data from 6 billion cell phones, you'll be able to say, you'll be able to provide some sort of information to users of cell phones, and just to warn them about the use of cell phones and cancer. But you need to get that information, 6 billion cell phones worth of information. You need to process that information, and then you need to present that information, that data as information. So it's a tall ask. What about collecting data from online courses? Now, we are currently in a situation, it's 2021. We're all in lockdown all over the world, and courses, university courses, college courses are being delivered from home. So I'm a teacher and I'm delivering many of my courses from home, and students are at home. And so it's not a classroom situation at the moment, but it means that there's a big spike in terms of the amount of usage that computers are having and the amount of data that's being created, from online courses. And so we can find out how effective those courses have been, and which means that we can improve the courses. So, what is big data? Big data is data that is so big, there's so much of it, that it cannot be processed or analyzed by traditional means. Okay, it's big, it comes fast, and it's so diverse. There's so much different types of data that we'll see. So, yeah, there you go. It's too big to fit on a single traditional computer server. The make or structure of the data is so diverse. Text, audio, pictures and JPEGs and images, video, different types of data. And then, of course, the data is very high speed data. It's streaming data. It's coming through your broadband pipes. All sorts of different data. So, the three defining characteristics of big data are volume, variety, and velocity. Volume, variety, and velocity. And you can see in this this table here, in the picture here, volume is all about the size of the data: terabytes, records, transactions, tables, files. Then we've got variety, and is the data structured? Is it unstructured? Is it semi-structured? What kind of data is it? And then we have velocity, the streaming of the data. How fast is the data moving? Can we put it into batches as we shift it from one place to another? Velocity. So, with volume then, looking at volume, when the size of data is too big to fit onto a traditional server, because that's certainly the case with big data, the data is far too big to be able to fit onto a traditional server. So therefore, the data must be distributed across a number of servers. And there we've got a drawing there of just that happening. So we've got here a master processor, and then we've got a number of super processors who can also deal with all the different types of data. It's just so big. It's the only way you can do it. A distributed system is required of multiple servers. So an example, when a single relational database doesn't have the capability to handle a large data set, the data set must be broken down and the data spread across a network of computers in a distributed database system. The data can then be processed to produce information. Yeah. So there's got to be a way of creating a database system, distributed database system, which works, all the computers, all the servers work together to enable the processing of the data and then to produce information. Variety. So the variety it's all about the lack of structure of big data. The lack of structure of big data makes it so difficult to store, process or analyze because you've got different types of data. You cannot use the rows and column structure of a relational database because the data is so varied and can't fit into that traditional structure. So there's a problem right there. The variety of data that's being used in big data. And some of the examples where that data is going to be coming from: networked sensors, so temperature sensors or wind sensors, video surveillance, video surveillance. We've cameras in the street constantly taking photos and videos for use for the security services. Smartphones, constantly connected to the internet, 24/7 access to information, videos, text, searches on Google, etc. Mouse clicks, and the effect of those mouse clicks. So these are continuously streamed and needs to be captured and processed. That data needs to be, that streaming data needs to be captured and then processed to give us the information. And lastly, the velocity. And so we looked at variety, we looked at volume, variety, and lastly we're going to look at velocity. Velocity refers to whether the data is in motion or at rest. So if it's stored, then it's at rest. If it's being streamed, it is in motion and has a velocity. So big data requires a new breed of networking technology to handle changes in data and to then transmit that data quickly. And in subsequent videos, we'll be looking at some of the networking technology to do with big data. And here's a diagram of the ideas behind the network. You've got to have a meshed network that allows for numbers of virtual machines, numbers of databases that can interconnect with one another, and it allows them to share information and to do the processing for each part of the information. So there we have it, the three characteristics of big data: volume, the size of the data, how much of it there is, the variety, its structure, whether it's unstructured, it's semi-structured, again because of the types of data that are being streamed, and of course the velocity being the speed at which that data will travel, be it video, text, audio, and of course all that data will travel at different speeds depending on where they are, where they're coming from and what they are. Volume, variety and velocity. So in our next video we'll be looking at distributed databases, machine learning and solutions for big data like functional programming, because we need to know a little bit more about how these different types of data can be distributed across numbers of servers, and how the patterns can be recognized. By using machine learning, we can recognize patterns in the data and therefore begin to store them effectively. So that's it from me. I hope you like the video. If you do like the video, then like the video. Don't forget to hit the subscribe button to like the video and leave a comment or a question. We will answer questions as we can. Don't forget to click the bell, because if you do that, we will notify you when new computer science videos are released. My name's Colin Baptiste, and from gradeacomputerscience.com, we've had fun. I'll see you in the next video. Cheers.